Hi guys, this is Vishal Singhal from SalesStrat. Uh, Today we have very interesting topic on our webinar Disrupt 4.0, which is impact of AI on financial services. And I have Prabhash Thakur, who is AI and ML practice leader, and uh, he will be taking us through the presentation here. So if you have any questions, you can put up in the chat window or question panel, and we'll be able to uh, respond to them at the end of it. Uh, as an outset, you can fill up the survey here, so we will know how many people are coming from where. Over to you, Prabhash.
Yeah, thank you, Vishal. I hope you all can see my screen, and it's 8:30 India time. So first, welcome to this webinar on impact of AI on financial services. It's late in the evening, so I really appreciate all of you joining. And I know some people are joining from different time zones, so I truly appreciate that. I just want to take a moment to thank Cellstrat for organizing this weekly webinar on AI and machine learning. My name is Prabhash Thakur, and I work with Centalon as AI and machine learning practice head. Centalon is a new age, IT company with focus on AI, machine learning, cloud, and Salesforce implementation. So with that very short marketing, let me just go ahead. The structure of this webinar is that first I'll take you through the slides. We'll talk about some of the things that are happening in the industry, and then I'll demonstrate one particular use case through a piece of code. And after that, we'll leave about 15 odd minutes for a Q&A, and you're welcome to ask any questions that you want to be answered. Okay, one request is, go on.
So there are still some people left to be answering on the poll. Please respond to the poll, please, so that we have all the data here.
Sure. Yeah, and the purpose of the poll is really to improve our webinar in future. We just want to understand a little bit about your background, what you do, so that we can tweak our webinars in future. Okay, so let's move on.
Sure. So we have 82% or 80% people here in technology and about 10% in financial services. Others have not responded, but let's close the poll here and go ahead with the presentation.
All right.
Go ahead.
Okay. So let me just start. All right. So if you are working in financial services, or if you have, as a technology person, helped any financial services company, you would know that financial services is a bunch of decision making, and since they have a lot of data, this decision making is often data based. While we hear AI and machine learning in terms of chatbots or automatic cars and so on, its role in something what seemingly mundane but very important like financial services cannot be denied. And every day we live and breathe AI without really realizing how much of an impact it's having in our lives in terms of financial transactions that we do. So on this slide, what you see is some of the decisions that financial services executives need to make. And the first one is creditworthiness, which is, whether somebody should get a loan or not. And this decision could be for an individual, it could be for a corporate. And similar decisions are also made if a company is, let's say, an insurance company. Should they give an insurance to a person or not? Similarly, if there is a mortgage, thing, which is not a personal loan, but it's an asset-backed loan, and there again, you have to make similar decisions. Every time we swipe our cards somewhere, in a matter of fraction of seconds, the system needs to decide whether this is a fraudulent transaction or not, and that again, is very, very data driven. Thirdly, investments. A lot of us who use our financial institutions, our banks, as wealth advisors, and they need to make a decision on which stocks, which bonds, which forex instruments to invest in. And lastly, sales and marketing. and you all must be getting, SMS and phone calls, and from that, at least I am sure that, the system is broken, because a lot of times I get messages about things I truly don't need. Now, these four things that I've mentioned this is not an exhaustive list by any means. There must be many, many other decisions, but I hope this sort of, clarifies the data-based, decision making in the financial services industry. Okay, so let me just take you through how, just one use case of, how decisions are made currently. So for credit decisioning process, there are credit scoring agencies, and they work on something like what you see on the screen. They have 5 or 6 broad criteria. For example, payment history, credit used, length of your credit history, frequency of, you using new credit types of credits, and different types of credits that you're using. And these are assigned some weights, and within each of these categories there would be a couple of questions as to how late are you paying in your some of the existing credits that you're using. If you're paying late, how old is your delinquency? Are you paying within 15 days or within a month, or you've not paid for 3 months? And then what is the amount of that delinquency, and so on. And similarly for credit use, they would say, of the overall credit availability that you have, how much are you consuming? Length of credit history, how long you've had the credit history with them. And if you are using too much credit, in a very short period of time, that again is a bad. And if you're using, different kinds of credits like loans and credit cards and so on, that's better. And through this, sort of question and answer, they come up with some sort of a weighted, score, and that score is distributed in a range like 300 to 850, and it decides the credit worthiness. So if you are, in the top score, then you have an excellent credit rating, and you get a lower, interest rate, and from there on it goes downwards. Now there's a problem with this approach, and the problem is that this is a hand-coded rule based on human experience. Now, nothing wrong with that. With human experience, we've been managing, a lot of, decisions so far, but it's purely experience-based. Over the years, people have, sort of understood what it takes to, give a credit, and they have built this rule. But the problem is that if this sort of rule means that if somebody has a poor score, he never gets a loan, which means he doesn't have relevant transactions, and consequently he doesn't have any credit history, which means he has a poor score. And this approach is not customized to individuals. So this approach is one size fits all. There could be an individual who has a reasonable financial backing. Maybe he is habitually late in paying his bills, but he has the ability to pay back. So it doesn't take care of it treats market as one monolith, rather than grouping people based on their behavior. And it also targets people who don't need the credit. And come to think of it, financial services is nothing but a financial and an intermediation system whereby people who have surplus money tend to give it to people who have less money or who need credit and have the ability to pay back. But since this is a purely score-based system, it tends to target people who may not need credit at all. And if we needed any data point to sort of prove this, there's a whole industry called alternate lending, which has come up. And in this industry, there are companies that is peer-to-peer lending. Now there are companies which are collecting data on people's behavior through these alternate channels. So there are companies like Factor Trust, which go and figure out people who don't have banking accounts in US, how they are paying back on, let's say, through to the pawn shops, to companies from to retail shops from where they buy goods on credit and so on. And this data is very useful because if we never had the data on people who've not been given loan, then it's very hard to create a model on whom to give loan or not. But if you are suddenly able to access that data, then that becomes a new business opportunity for the financial services industry. So with AI, we can do a much better job because machine learning does not depend on some predetermined equation. It looks at people's behavior And based on that behavior, it would predict whether somebody needs a credit or not, and if he needs a credit, then whether he is credit worthy or not, because it's able to recognize patterns from the data rather than somebody hand coding it. And second thing about machine learning is that it doesn't have hard boundaries. It gives you probabilities of somebody paying and not paying and so on, which means that people who are very close to the boundary, somebody who may be denied credit, but it's very close to the cutoff. There, as a credit manager, you could take a view that this person may be worthy of credit because it's not too far from my decision boundary, and then you could take a view whether your interest rate should be high or low or so on. And over a period of time, people's income changes, their buying behavior changes, their credit behavior changes. And today's millennials are in the credit market, but our models have not changed that much. But the beauty of a machine learning based model is that as people's behavior changes, the model is also automatically, you can change that model accordingly, and you're able to make much better decisions. Let me take one more use case. In this particular use case, we'll talk about investment decision process. So, typically the way investment decisions are made is that any portfolio manager would first shortlist the stocks based on the past risk, past return, some of the financials and so on. And then out of those shortlisted stock, there is a deeper study of its financials, its balance sheets, its P&L and so on. And then there's one more filter. And after that, people go in the market and seek opinion from the customers of that company, from the suppliers, from some people who have a better understanding of that company, just to make sure that they're not making a wrong investment decision. And after they have this information, then a complex spreadsheet model is built where all this information is factored in, and based on that model, a buy or a sell decision is made. Now let's take a look at how well this process is faring. So this graph, which I picked up from Bloomberg, tells you how much money is being taken away from the actively managed fund and is being put into passively managed funds. And the meaning of passively managed funds, for those of you who are not aware, is that there is no analysis on the companies. All these funds do is to mimic the behavior of the index. So if Sensex or Dow Jones moves in a particular manner, this passively managed fund is also moving in that direction, because its portfolio is just a smaller version of Dow Jones or a Sensex. Which means that as investors in US, people are not confident that all the analysis that goes behind in actively managed portfolios is giving them the sort of returns that they are expecting, and they prefer to sort of save on the fee of the actively managed funds. And consequently, what you're seeing is the kind of behavior where the money is being pulled out of actively managed funds and being put into passively managed funds. And I wouldn't be surprised if India also catches up to this particular trend, because a trend that starts in US kind of catches up in the rest of the world. Okay, so what do we need? If we want to do better than passively managed funds, what we need is that instead of opinion of a few people, we need facts and opinion at a fairly large scale, and some of it is already happening. So there are companies which, for example, are tracking, let's say, retail sales. So instead of just depending on vendors and customer surveys, what they do is they take satellite imagery of the parking lots, and they say that how is the number of cars changing over a period of time, which means you should be able to take the images, you should be able to count the number of cars at different points of day and so on. And of course, those of you who understand computer vision, you would know that this is really possible. It's possible to count the number of cars and so on. And there's a company called RS Matrix which does this satellite imagery and car counting stuff. And then there are people who invest in commodity markets. So they take pictures of cornfields and so on, just to understand what would be the supply of these commodities, agricultural commodities, in the market in coming months. and that way they're not blinded by the fact that there is some market rumor or something like that, and there are companies which are taking satellite imagery of that. And similarly, if you want to know how well exports of a particular country is doing, or economic activity of a particular country is doing, then there are companies which are able to take satellite imagery of ships in the ocean close to the harbors of the countries that you are trying to study. And there is a company called Orbital Insights that takes all these satellite pictures for ships and oil rigs and so on. So a lot of work is already happening. Since it's early days for machine learning AI, I'm sure this will improve quite a bit. But clearly, some portfolio managers, some hedge fund managers have realized that just depending on information from few sources is not enough, and they need to broaden their sources of information to make proper investment decisions. On the right side, what you see is something called email scans. Some of us would have already experienced this, that these days a lot of invoices come via email. So imagine you are you are trying to invest in a cell phone company, or rather mobile phone manufacturing company, and if you have an ability to read invoices from people's email, then you could treat that as a representative sample and make a decision, whether the company's sales is doing well or not. Now, you can't scan people's emails just like that, because there is an issue of privacy here. But there are companies which are able to speak to consumers, and people are willing to opt in some of this information to these companies, and with email users' permission, they're able to scan their emails for invoices and make those decisions. Similarly, so there is a company called Eagle Alpha which does this, and maybe if you want, you can just take a look at what they do. If you all, some of you may be too young to remember this, but some of those who are my age probably would remember Enron. And when Enron went bankrupt, the government asked them to open up, their emails, and some of those emails are in public domain, and they are being used to model for forensic behavior of fraud in companies, as to what sort of things senior execs do, which can give you an indication of fraud. So for example, are they investing too much in a particular company, and are these investments being made on a very, very short time, and so on. So that again is an interesting area which is coming up. Another area that we are seeing is people are scanning Twitter, news sites, and regulatory compliance websites to find out what's going on in the company. So, for example, there's a company called iCentinium which scans Twitter for sentiment about a particular company, and that is being fed in investment decisions. Similarly, Ravenpack, for example, does news site analysis, and I'm aware of a company called Audit Analytics, which looks at compliance, findings about companies. Because if, let's say, SEBI or any SEC has some issues with a company, it goes to a particular website, and if your engine is somehow able to scan those things and make decisions, then that's a very useful thing. Now, you all would appreciate that you can't use any one of them alone to make a decision. You would sort of have different factors, and you would use different signals to make a decision. And it's always a bad idea to have a sort of a pointed answer that the stock would go by 10%, or the profit would go by 10%. Typically, like any other machine learning model, you would have answer in probabilities, and you would have answer in ranges, and that's how investment decisions are usually made, and that's how recommendations are made by these companies about increase or decrease in economic activity, or in business impact. Okay, so now, if all this seems like science fiction, do consider this. There is this company called Sentient, which does quantitative trading. Now, quantitative trading is not a new thing, but like most of the things, it was, human-coded rules. But this company, makes investments purely based on its machine learning algorithms, and part of the investment is, done independently by these algorithms. Okay. So let me just quickly launch one more poll, and for those of you who have joined us a little late, I am just we are asking you a few questions just so that we understand where you come from, what your experience is, and so that we can tweak our future webinars accordingly. Okay, so I just asked a question, which is, do you use AI/ML? If you have time, just please respond to that. Okay. While we are all big fans of artificial intelligence and machine learning, let me tell you that it's very easy to fool some of these systems, and we can't lower our guard, especially if you're working with financial services. So here's one study that was done, and details you can look up in the internet. Somebody did an image classifier, and the image classifier correctly identified a panda. On that, some image pixels were added to which to human eye looks like a noise, but it's not a noise. It's it's a signal which moves you from the classifier very marginally to the other side of the classifier. And with very high precision, the AI algorithm started detecting that panda as a given with almost like 99.3% accuracy. And this problem gets aggravated if your algorithm is trying to detect multiple things. So if you have a multi-class classifier and that classifier is detecting, let's say, 10, 15 things, then your algorithm would be quite brittle, and you have to build defensive measures against any kind of hacking, any kind of malintention of people. Okay, so there are many ways to breach an AI system. And the first one is what we would call an adversarial input, which means that any fraudster would try to send variety of payloads. They would try different things. And often these days people don't try it by hand. They have again a software to do this, whereby they're trying different things and trying to continuously test where the system can be breached. And this specifically I'm talking about area of payment frauds and so on. The second method used by fraudster is to feed the wrong training data. Now, we all use, in our emails, you have, if you get a spam email, then you can click it as spam, and then, what happens is that in the background, your email service provider is collecting those email addresses and, using its classifier to make a spam versus non-spam decision. But imagine for a moment, if some guy goes and clicks a lot of genuine messages as spam, then what happens is that that classifier is obviously making mistakes. And that's how you feed wrong training data to the system. So for example, if your algorithm is doing automatic trading and there are people who are aware of it and they make deliberate wrong trades, and that system is able to learn those wrong trades, and one fine day when you have taken a large position in the market, then they do a different kind of trade, then your system won't be able to handle it. So as designers, as software engineers, we have to be aware of these tactics, these risks that come with any AI-based implementations. So the question is, how should we go ahead and build defenses against any attack from the system? The first is that we, at any point in time, periodically, we have to take a look at our data and keep doing sanity checks on the data, which means you visually see and see whether data behaves in a particular pattern or are there outliers in the data and so on. And we also have to look at recommendation of our own system and see, is the recommendation deviating too much from the past? So periodically you have to check your machine learning system, especially if you have put it in automatic training mode. And then you also have to make sure that if somebody is trying to access the system, they don't get feedback about what's wrong with their access too quickly, or sometimes you should not even give the feedback at all. So for example, if someone is accessing, trying to make some payment thing, you could just say unauthorized, or you could just say that, but you don't have to give the, exact reason of why it's been unauthorized. So as a result, or if you delay the thing, if you send it by email and so on, you're making sure that, the people who are using the software also is not able to make a decision on their behalf if they have any malicious intention. And in trading, there is a concept of stop loss, and I think which is that if you go too much from your current position, then what you want to do is, if you have bought the shares, then you sell it and so on. And if you have a if you have a sell position, then you make the reverse sort of action. So those things that we have all learned over the years, that's something that we should sort of continue doing. There are a lot of good practices in traditional data science, especially around visualizing data and doing risk management, understanding anomaly behavior, and so on. And we have to continue doing it rather than following any recommendation from machine learning system blindly. Okay, so that was a sort of short talk, and we are almost like halfway mark of our webinar. So let me just show you one small code. It's about corporate bankruptcy, and the idea is that if I know which company is going to go bankrupt, then I'm better off not giving loans to that company. And if I already have the loans with that company, then I should not be extending new loans. And if I have the ability to call back my loan, then I should be calling back those loans. So that's a very critical decision, especially, you should remember that, as individuals, we take small loans, but corporates are allowed to take large amount of loans. And, any one corporate going bankrupt can dent a bank's, financials very, very badly. Okay, so we are looking at this data. Some of you might be familiar with this data, but for those who are not, I'll just take you through what this data set looks like. Okay, so we have 5 tables, and for this code demonstration, we'll just pick one of them. So we have data from year 1, and then the bankruptcy is tracked in year 6. Similarly, we have for data for year 2, and bankruptcy is tracked in year 6, 3, 4, and 5. And the idea is that we want to make sure that we are able to predict data bankruptcy from each of these files separately. There is a way to sort of use all the 5-year data, but for now we'll just use 1-year data. Okay, so what you see here is the description of the features, or the input variables that we'll use to make this decision. And if you read it carefully, what you will realize is that in accounting, if you've learned some of these ratios, so there are some things which are profitability matrix, for example, net profit by total assets and so on. There is something around gross profit and so on. There are measures around capital efficiency, how well I'm able to use that capital to generate my profits, and how much am I able to retain as earning, and so on. There are measures around inventory turnovers, and which I'm trying to see where it is. Yeah. So total sales by total assets. Unfortunately, it's not in an order for me to explain to you, but that's how it appears in data. So we have to keep it in a particular format. Then there is something about the size of the balance sheet. What's the total asset? What's the working capital by assets? Liabilities, and so on. And then there are some liquidity ratios around how much of short-term liabilities by total assets, for example. This is a liquidity ratio, and I already talked about inventory turnover and so on. Yeah. So somebody has done this analysis, and I'm sure anyone who is into making decisions about company, about any kind of investments would have seen some of these numbers before. So let's see. So let me just take you to the code and see what this code is. So let's just first look at the data. The data appears like this, which means that instead of all these attributes horizontally, it appears in a vertical format, because this is a VECA format where all the attributes are first put vertically, and then all the data is described. So what we'll do in our code is that first try to get these do some pre-processing and get rid of what is appearing on top. Okay, so if I pre-process, my data looks something like this. And while I am taking you through the code, let me take you through let me, quickly launch the third one, which is which use case do you really like? Okay, so
So, Prabhash, I'll interrupt you here.
sure.
So, we have about 60% of the audience we have today is are technologists, and 40% are non-AI ML users.
Okay,
So, and
okay,
let's see what this poll shows.
all right, okay, fantastic. Okay, so
So, 55% are showing investments as their exciting use case, and 23% marketing, and about 30 odd percent credit decision. So, largest is investment, and second is credit decision.
all right, fantastic. Well, that's a
So,
very
it's
useful. Yeah, yeah. Okay, so if I pre-process the data, what I would do is that I would, put all my, column names in a horizontal format, and I'll show you in a minute how we do that. Yeah, and then, what you have is a comma separated values of, all those variables that I showed to you, 64 of them in total, and the last one, sorry if it's scrolling too fast, is the class. Zero means it doesn't go bankrupt. One means it goes bankrupt. I know it sounds crazy. One is a positive number and we are calling it bankrupt, but that's the quirkiness of machine learning programming, where the class that I'm interested in is given one. Okay, so let me take you through the code. Okay, yeah, here. So I hope you all are able to see it. So the first, as usual, we import our modules. And then, and as you can see, we are looking at pandas, we are looking at sklearn, we are looking at IMB learn, which I'll talk about in a moment. And here again, I am going to describe my data, which I already talked about in the slides. Okay, so it's all again, described as to, so for example, you see sales this year compared to sales previous year. So we are interested in growth, we are interested in, profit growth, we are interested in, we are interested in our capital efficiency, operating expenses by total liability. We are interested in, our, again, this is the profitability measure. We are interested in inventory turnover, as you can see here. And we are interested in our balance sheet items and so on. Yeah. And then there are some liquidity measures, profit by total liability and so on. Okay. So this cell essentially converts Veka format a CSV format. This is where we take all the vertical stuff and then put it in a horizontal format. And this is what we say that in first you split lines, and if there is a data, you take it horizontally, and if you see something called attribute, then append all of them together, join them as headers, and then save it as in a CSV format, which I show to you for a moment. Yeah. Okay, great. So for now, in terms of hyperparameters, I'm only taking year 5, which means data for year 5 and bankruptcy in year 6, which I don't know if it's good or bad, but it's quite possible to do it for year 1 as well. It's just that for this demonstration, I've taken as year 5. Now, test share, it just means that from the training data, I'm going to take 10% of them for testing and 90% of them for training. And then, as usual, we'll load our data set, as you can see. And what you see is that I have 5,910 rows, as in I have so many data points. But the problem is that some of them data points are missing. So what should we do with the missing data points? One simplest answer is that you delete those rows. The other is that you impute them, but in such cases, I would recommend not to impute, because what happens is that when you impute a data, then you're taking mean value of all the companies and are replacing it with a company that may be in trouble. So it's better to drop them. So after dropping, you see from 5,910, the number of records that I have is 3,031. So it falls drastically. Yeah, and now let's see our x and y variables. Here again, I just allocate y to my class values, and I allocate x to everything else. Now I'm going to print, the number of rows which have 1, which went bankrupt, and the number of rows which did not go bankrupt. And as you can see, it's 102. rows which went bankrupt, 102 companies which bankrupt. And these companies, just for your information, these are mid-sized companies taken from emerging market. This was collected by a Polish research group. That's why Polish bankruptcy data. Now look at the ratio: 102 positive cases and 3031 as the total number of cases. So we have 2% of the companies which went bankrupt, and this is a situation you will always face in any financial services decision, that the data will be highly skewed because the number of people who don't pay up, number of companies which go bankrupt, the number of people who would be interested in your marketing message, and whatever measure that you take in would be really small compared to the total universe. And which means that if I'm going to train my data, my algorithm, irrespective of which algorithm I take, this is going to learn the algorithm, the behavior of the majority class. And there are two ways of handling it. One is that you oversample, and I'll talk about it in a moment. So let's just go through the oversampling, and then I'll talk about what else can we do. So what we do here is that we take the fraud data, and then we make oversample it using a technique called SMOT. There are many other oversampling techniques, but what SMOT does is that it sort of takes based on the behavior of those data points which were bankrupt. It takes intermediate points and sort of creates similar, not exactly same, but similar data points. And if I do that now, as you can see, I have equal number of positive and negative sample, which is fantastic. And then we'll run it and we'll see how the results are. If this doesn't work, then you have to try something called ROC curves, where you move the threshold and see how it behaves. If that too doesn't work, then you have to do work on something called a feature engineering. It's a separate subject by itself, and maybe one of these days we'll cover it in one of the webinars on how do you do feature engineering when things don't work very well. Okay, so you have to shuffle the data so that if data is being stored in a particular order, and sometimes it's stored in particular order because it may be based on date wise and so on. So we do that, and then we split that into training and test. Yeah, so I have 585 data points which are test data points. Okay, so we do some standard scaling, which I'm not going to talk about because I'm sure you are aware of it. And here I'm using a neural network, multi-layer perceptron classifier. You could use other things as well, but I just thought this is a fairly handy classifier and reasonably nonlinear for us to make a decision. And I'm using 3 hidden layers, 5, 17, and 3. Why these? Some you can use some heuristics, and you can sort of do a little bit of hit and trial as well to come to these number of hidden layers. I've taken learning rate as 0.001, which is quite reasonable because it's not too low and it's not too high. So, it should converge very quickly. And I've taken 5,000 as iteration. If you have more data points, maybe, you need more iterations. Okay, so if I run all this, what I'm getting is that I have actual bankrupt cases as 277, and I have predicted 289. So I'm, doing a little bit of false positive here, but that's okay because it just means that some companies, deserving companies, may not get credit, but at least I'm able to capture all of them, which should not be given credit. And that measure is called recall, which means out of all the ones which were likely to go bankrupt, did I predict all of them? And the answer is yes. And the precision is the other metric, saying that of all the ones that I predicted, how correct was I in terms of the minority class, or in the class that I'm interested in, which is the bankrupt class. So I have a total misclassified sample of 14, and I have an overall accuracy rate of 0.98, which I believe is a fairly good accuracy rate. If I had not received this accuracy rate, as I said, I would have tried, ROC curves. I would have tried, feature engineering, and see what sort of, accuracy I'm getting. Okay, so that's pretty much about, our discussion. So now let's just, open the floor for any questions that you may have. Okay.
We have about 20 odd minutes, so you can post any questions that you may have, and Prabhash will be able to respond.
Should I stop sharing my screen, Vishal?
No, no, keep it there.
Okay.
Also, some people have asked if you can share the files of the data set that we have used, but we won't be able to share the files. But this webinar is being recorded, so we will be posting it on our Self-Stat YouTube channel. Also, since you have joined this webinar, we will be sending out newsletter around Monday or Tuesday. That's when you will receive the recording in the newsletter itself. Also, we'll be starting in August. We'll be starting a machine learning program, a certification program of about 5 weeks or 50 hours, comprising of 20 hours of instruction time, 20 hours of self-study or MCQs, projects, and tutorials, and 10 hours of project work. So, somebody is asked, can you tell about that module? Which module? Can you please specify? Prabhash,
Okay.
was
Is
there
that?
any imported module?
Yes, it was. Yes. Yeah. I
So,
thank you for reminding me. Let me just try to go back to the module. Yeah. Yeah. So that module is called IMB Learn. So Vishal, it'll be great if you can tell me the questions, because that way.
sure, sure,
Yeah, because I could not see this question.
sure,
Yeah,
sure.
so this module is called IMB Learn and oversampling. This is what helped us, do this smart business. I could have done a random oversampling, which means take the same thing and repeat it, but I chose smart. But this IMB Learn module is the one that helps you do it, and that way we were able to get a fairly good result. I tried without this module and I was getting really bad results, something like 10% accuracy and so on. So I would have had to do different things, but thanks to this smart, I got a fairly good results. Yeah.
Another question is, how important is the time series for ML or AI in financial services? If possible, some use cases, please.
Sure. So, time series is a very important, subject in itself. And if you remember old days of time series, where we used ARIMA and exponential smoothing and so on. The problem with these methods is that you just take the previous, performance and feed it forward, and then hope that something new will happen. It'll predict something new. So it can be used to predict, demand for a company, revenue for a company. You can use it to predict how Sensex will behave and so on. Yeah, but the problem is that it doesn't work very well, because you can't predict future just based on the past performance. But if you were to expand this and say that I am going to predict my future based on not just what the past performance has been, but also based on events. So for example, can I say that people are saying some great things about a company, and this company has had a great run so far or not so great run so far? How would it impact its profitability or revenue? So if I'm able to somehow combine past performance and some of the events, if there is a special sale, or if the competitor has reduced price, what will happen? And I also have the past performance. If you are able to combine these two, then you get far better results. And if you have time, go look up RNNs, because they are being used to do precisely this, where we can use these methods to do a better job of time series, where you mix time series and one-time events.
Okay, another is, you mentioned the risk of intruders who might intentionally disrupt the models to classify the spam emails. How do we check the data constantly to verify high deviation? Next, after training and deployment, when it predicts an email as spam, should someone manually spot check the emails if it's spam, or rule-based check, or is there any other way to constantly monitor? Any real example, if possible, will help.
Sure. So there are two, three methods to do it. One is that you can definitely, in your input data set, create an anomaly detection or some kind of clustering mechanism, whereby you say whether these some of the new input data points that you have received, are they part of a pattern, deviates little bit, or deviates too much. If it deviates too much, then it deserves a manual inspection, and you have to see where does it deserve, why does it deviate too much. It could be a bona fide case, it may not be bona fide, and that's how you figure out how this should be done. On rule-based thing, yeah, I mean, you can use some of it, but the point is that you're trying to move away from rule-based, because if you have past rules and if you have machine learning based rules, then that is already doing a good job of classification. We are trying to think of where this could be problematic. You could put some things like stop loss is a rule based thing. If something breaches a particular price, then you want to take an action. Similarly, if particular columns are breached, you want to take an action. So you could put one or two rule based things, but a cluster based algorithm would also give you reasonably good results.
Any more questions here? Yeah. So as I mentioned before, we'll be putting this recording on the Self-Start YouTube channel. We won't be able to share any files or code here. So no, sorry about that. And how is the adoption of AI in financial services across geographies? Which region has the highest adoption rate, and who has the lowest?
Okay, this is subjective, so I'm just going to give you my opinion. All right. So I find that, I mean, if you have seen the examples that I was giving in terms of data providers, because you need, before you build models, you need data as well, right? So if you see the examples of data providers, more or less everyone is from US, which means these guys are deploying their satellites. They're I mean, capturing somebody's behavior, credit behavior from a pawn shop, from a local money lender, is a very hard problem. But people are being put in the field to capture that behavior. So definitely, financial services companies are doing some work in it. Most of the work is happening in US. From the clients that I've worked with, they all have shown interest, but you have to realize that it's a fairly new thing. Sometimes the problem is availability of data. Sometimes it's the fear of change. Sometimes it's the right sort of sponsorship from people. But I believe that slowly and steadily we are getting there. I have seen companies looking at their insurance decisions to be made based on some of the neural networks. So that I'm personally aware of. I am aware of companies looking at fraud detection as an active area using machine learning. We have some experience in that. So it's happening definitely. And in India also, we see a lot of interest in it, a lot of inquiries in that. But I think it's still early days. That's what I would say.
Okay. Another is most of the attributes you have shown in bankruptcy case study, if not all, are related to fundamental analysis, and we get the data once in a quarter or in periodic manner. So how much it is used in real time?
Sure. So you're right. I mean, this data was because this data was available to us, we use that, and as you can see, it does a fairly good job of predicting bankruptcy. So you could use fundamental analysis data instead of taking subjective decisions about this financials, where you say that if companies liquidity ratio is so much, I'm not going to consider it. You could let the software bring out that pattern for you, and then make that decision. So from that perspective, it's definitely one step ahead, that instead of hard-coded rules, it's machine learning based rules. And as I said, you can use this along with some of the information that I just pointed out, which the whole field is called alternate data, where you try to capture alternate data. But alternate data is useful if you're already invested in a company or want to invest in a company. Bankruptcy is the reverse problem, is where you want to get away from. So both are important, in their own rights. Yeah.
So Prabhash, some people are asking if this code would be available on GitHub.
I'll have to sanitize it a little bit, and then probably we can make it available. Yeah.
As of now, it is not.
No, because it needs a little bit of sanity check.
Right, right. Okay.
Yeah.
What kind of hardware you are using to run the neural networks?
I use my laptop, so this is a fairly short, as you saw, this is like 3,000 records multiplied by 64 rows. So any laptop would do that. Now, if you have a data set, which is, let's say, in tens of thousands, like 50,000 rows and so on, then it would take, again, your laptop can still do it. But if you're crossing that sort of, you're getting in lakhs and so on, then you have to move to a server. If you are getting like 50 lakh or a crore, then you have to go to a cluster. So that's sort of a computation power is that's broad sort of computation power that you need.
Okay, some more are coming. Just hold on. Financial services constantly look for fraudulent participants. AI is used in some places to predict the participants involved in the transaction. Is there any real example of AI model which is used here?
I'm sorry, I didn't get the question. I mean, is there an AI model for looking for fraudulent transaction? Is that the question?
Yeah, AI, is there any, I'll repeat, which financial services constantly look for fraudulent participants. AI is used in some places to predict the participants involved in the transaction. Is there any real example of AI model which is used here?
Sure. So as you rightly pointed out, payment fraud is not a new area, and over the years, people have been tweaking it. So every time a fraudulent transaction happens, somebody figures it out, and they say, okay, let me just close that tap. So for example, let's say you do some transaction at middle of the night, and then you do again next day. It seems like a fraud because you're trying to cross the maximum level of, you're trying to quickly encash on the fact that there is a maximum limit on cash withdrawal. So that looks like a fraud. Maybe it's not, or maybe you that's how you behave, right? That's how you behave because maybe you work in night shifts and you take some money out, and after a while you want to take money out again. So these things have already been coded by human beings. Now what we are seeing is companies are saying that I have all this data. I've already closed some of the gaps that I had based on my experience, but I still get a couple of thousands of fraudulent transactions every month. Can you guys look at it and can you help us understand what's going on using some of the machine learning models? So I'm aware of it. Unfortunately, I can't share any more details about the clients, but I'm aware of it, yes.
So is there any AI model that can detect the participants to figure out the purpose of the transaction?
So as in, a simple classification like fraud, non-fraud is possible. Now, purpose, as in, why would you be doing it? Are you a genuine person or not? Is that your normal behavior and so on? That can be definitely built in a model, yeah.
Okay.
So I mean, we have to look at, somebody used the term use time series. Yeah, we have to look at time series of your behavior.
Let's hold on for another 3-4 minutes, and in between I'll just plug in my usual promotion stuff. So,
all right.
just be there, Pravash. I'm just switching to share my screen.
Sure. Should I stop, or you can do it yourself, right? Or
No,
should
no.
I?
Yeah.
Okay. Yeah, I can see your screen.
So, this is my number and email here. If you have any queries, you can send it to this email. Also, we have a Disrupt 4.0 group on this number given here. We share a lot of content every day or alternate day, which is not coming on Meetup, of course. There is not much space there to put in the slides or things like that. So if you want to be part of that group, you can send me a message on this number saying that you are so and so from so and so company with this role in that company and would like to join Disrupt 4.0 group and refer to the webinar that you have attended. So we'll be able to add you there. So you'll be able to get a lot of regular feed on whatever content we are sharing with our community there, as well as on social profiles. So you can also post your query on the meetup group if you want to be part of that WhatsApp group. Thank you. So back to you, Prabhash.
Okay. All right.
So
Do we have any other
another,
question?
yeah. So how likely are you to get time to upload it to GitHub? Some people are still asking.
Yeah, I'll just find time, and I'll, clean this up a little bit, and then I'll upload it. Shouldn't be a problem. Or, if you truly want it, maybe what you can do is, if you drop a note to Vishal, then we can, send it to you. Yeah.
Sure. Any more questions here? We are running out of time. I think we are good to go. So thanks, guys. Thanks for attending the webinar, and you are most welcome to attend future webinars. We have not yet decided on next week's topic, but hopefully from next month we are trying to get in some international speakers as well. I'm not sure if they will say yes in time. They have shown interest, and look forward to see you again. Thanks. Bye.